I'd like to thank the Professor a couple of presentations ago for bringing up the endemic problem we have in the industry in discerning the difference between process safety and personal safety, and what indicators you use, what precursors you look for to anticipate a process safety incident. But you're probably asking, if you're not really into this thing in a big way, well, is there any more structured approach that we can take, apart from just looking at potential hazards that we have in our plant and trying to work out what potentially can cause those and then trying to stop those, or identify those. So what I'm going to do over the next sort of 25 minutes is take you through what the International Association of Oil and Gas Producers has done since 2005, and also what the API has done since 2005. So thanks a lot for giving me the opportunity to speak to you this afternoon. And I just want to congratulate the organisers of this event. I mean, it's just wonderful. Denmark's not a big country, but when you look at the industry representation in this room, it's quite a lot of people. So, what is process safety? I'll explain what efforts are currently underway across the industry to standardise its measurement and therefore enable benchmarking. I'll also explain what the International Association of Oil and Gas Producers, or OGP, representing the upstream oil and gas industry, is doing in this area of intense activity and rapid evolution. And as you'll see, OGP has commissioned a task force, which I lead, to ensure that it has a seat at the table during this period, which ultimately will lead, I hope, to an industry-wide standardisation of process safety metrics. So, just a minute and a brief background. That's the state of Qatar. It's about 180 kilometres north to south and 70 kilometres east to west at its widest. It's a thumb-shaped peninsula that juts into the Arabian Gulf, and the capital is called Doha. The population is roughly about 1.5 million people, and they discovered oil all the way back in 1939. The giant North Field, you can see there at the top of the map, now understood to contain 900 trillion cubic feet of gas, or 20% of the world's gas reserves, was discovered in 1971. So that's pretty incredible. That's the world's largest non-associated gas field, 900 TCF, representing 1/5 of the world's reserves. Commercial development of that field began in 1991 by the state's national oil company, Qatar Petroleum. And Rasgas, who I work for, a venture between Qatar Petroleum and ExxonMobil, began production in 1999. The processing facility lies to the north within the Ras Laffan industrial city and is fed from facilities about 90 kilometres offshore further to the north, and they're right on the Iranian border. Well, they're about 1 kilometre outside of the Iranian border, and the Iranian platforms are 1 kilometre the other side. So they're the blocks of the field that are being developed first, as you could probably anticipate. The company now runs the largest LNG plant in the world, and as an integrated facility, produces both lean and rich LNG, LPGs, gas condensate, liquefied helium, and sales gas. It consists of 7 LNG trains, 2 large sales gas plants, and a helium refinery. The last 2 LNG trains we've just completed, and up until this year we've had 40,000 contractors on site, building what's been one of the largest expansion projects in the industry over the past 5 years. It processes around about 9.2 billion standard cubic feet per day and makes 37 million tonnes of LNG a year. In addition to that, as effectively a byproduct, we make about 350,000 barrels of gas liquids a day. So with such a huge and complex concentration of equipment and hydrocarbons comes inherent process safety hazards, and I've listed those down there, and I'm sure that all of us have at least some of those in our facilities around the world and around Denmark. These are the reasons, of course, that we're all interested in doing whatever we can to prevent a process safety incident, or in Europe, as they're known, major incidents. But how do you define process safety incident? It's instructive to begin with a definition, and I'm going to use the terms process safety and asset integrity interchangeably. Process safety is a term that originates in the US, whereas in Europe, asset integrity is also used. Now, the Baker panel's already been mentioned earlier, It was assembled to review process safety management in BP's 5 North American refineries following the Texas City disaster 5 years ago, and it defined personal or occupational safety hazards as those that give rise to incidents that primarily affect one individual worker for each occurrence. Process hazards, on the other hand, are hazards that give rise to major accidents, I should say, involving release of potentially dangerous materials or the release of energy through fires and explosions, or both. And process safety events can have, as we all understand, catastrophic consequences that may cause multiple deaths and other substantial damage to company reputation, earnings and the environment. 2 seminal events for the industry occurred in 2005. Early on Sunday, the 11th of December, a series of explosions and subsequent fire destroyed large parts of the Buntsville oil storage and transfer depot, causing widespread damage to neighbouring properties. 9 months earlier, on the 23rd of March, the biggest industrial explosion in the US in 15 years occurred at BP refinery in Texas City, resulting in 15 deaths and over 170 injuries, I should say. Until this time, some companies and trade organisations had established process safety metrics programs, but the programs differed from organisation to organisation and, of course, differed in their effectiveness. The Texas City refinery itself, in fact, was already measuring losses of primary containment incidents, which had got steadily worse from the years 2002 to 2004, increasing by 52%. That's ironic because, as you've already heard one of the speakers earlier today say, their personal safety record had been bettered year on year for the previous 5 years leading up to that explosion on the 23rd of March. So the reason that Texas City resonated as an incident demanding a step change in approach was because many people in this room I suspect, including myself, could see that many of the causal factors of Texas City existed in many of their other sites around the world. So clearly this was a breakthrough opportunity for the oil and gas industry to align on a common and effective scheme of process safety management. The Centre for Chemical Process Safety, or CCPS, invited many stakeholders from industry companies, associations and regulatory bodies to participate in the process safety metric project in 2006, soon after the Texas City refinery disaster. The recommendations from the Baker Panel and the US Chemical Safety and Hazard Investigation Board, or CSB as it's otherwise known, further increased attention on this work in 2007. In 2008, the Buntsville Major Investigation Board in its report referred to and concurred with the recommendations of both the Baker Panel and the CSB report. All acknowledged that 1, measures for tracking operational and safety performance will not provide early warning of potential major incidents. That is, a focus on precursor events for personal injury will not predict process safety incidents. And 2, the need for industry-wide lagging asset integrity performance indicators was also recognised. The CSB in its report recommended the American Petroleum Institute, or API, develop a new ANSI standard that would create performance indicators for process safety for the refinery and petrochemical industries, ensure leading and lagging indicators were identified for nationwide reporting, and include method for development of indicators. The key attributes of effective process safety indicators are that there should be few, they should be simple and well defined. Secondly, they should allow internal and external benchmarking for multiple stakeholders. Thirdly, there should be ample data, a sufficient number of events to be useful for continuous improvement. And lastly, the metrics should align as much as possible with other recent publications on industry metrics. So based on that philosophy, API began a 3-phase project on designing lagging and leading process safety indicators in July 2006. This has culminated in a recommended practice called 754 that was recently approved this month, in fact, only 2 weeks ago. So I'll just move on to some background information on the International Association of Oil and Gas Producers, or OGP as they're known. It encompasses most of the world's leading publicly traded, private and state-owned oil and gas companies, oil and gas associations and major upstream service companies. And no doubt a lot of companies represented in this room are also members of OGP. It was formed in '74, amongst other things, to be the industry's voice with an increasing number of regulators and increasingly complex regulatory environment. It also commissions from time to time task forces and subcommittees made up of members' representatives to develop upstream industry recommended practices. And recently, it has identified the absence of upstream industry guidance on asset integrity or process safety KPIs as an issue that justifies the creation of a task force. So in 2008, OGP published a document called Asset Integrity, the Key to Managing Major Incident Risks. And I guess if process safety is a new concept to you today, and you're in the upstream oil and gas industry, I'd recommend downloading that from the web. It's a good place to start in understanding the importance of recognising the difference between personal safety and process safety. This included preliminary guidance on the establishment of KPIs. So to build on this report, an asset integrity KPI task force was created and asked to assess whether further guidance is needed on the selection, development and use of KPIs, identify a limited set of leading and lagging KPIs to improve company process safety performance in the upstream industry, and also select KPIs suitable for industry-wide OGP reporting, effectively following what API had done for the downstream industry. The task force consists of about 20 members, including representation from most of the global operators, and the UK HSE is also represented. In addition to that, we've got a member of the API committee on the task force as well. Right, so this came up in the last couple of presentations, and so this should be fairly illustrative of what the professor was saying in terms of needing two triangles. You can't have one triangle with precursor events at the base as leading indicators that point to both process safety and personal safety incidents. So the personal safety triangle model that we're probably all familiar with was based on empirical research by a fellow called Bird some time ago. And he found that for every serious injury there was a proportionally larger number of minor injuries and a still larger number of near misses. It's since been shown on most sites, including mine, that a successful reduction of the more minor precursors to serious injury will ultimately reduce the number of these serious injuries. But an assumption that the precursors to serious injury were also the precursors to major accidents by some in the past has led to a so-called blindness to major risk, as Professor Andrew Hopkins has put it before. It's now clear that precursor events such as gas leaks, fires and demands on safety instrumented systems are much better precursors to process safety disasters. And as Hopkins has suggested, and the gentlemen that have spoken to us today in the airline industry know, that airline industry has had it right for a while. No airline in its right mind will try to convince the travelling public of how safe it is by pointing to the injury rate of its baggage handlers. So to this end, two triangles, or two sides of what's now depicted as a safety pyramid, if you like, sort of got, well, 3 dimensions, with separate sets of precursors, represent a much better predictive model for process and personal safety incidents. The model indicates a kind of continuum from the so-called lagging indicators at the top, descending to almost exclusively leading indicators at the bottom, as the lower leading tiers are indicative of performance at higher tiers. And you can see that that's supposed to be indicated on that diagram by the tapered arrows pointing up and down. The API recommended practice is built on duplicating the tiers of the personal safety triangle, both in number and also in the predictive connection with each tier above. The analogy between each of the levels of the respective triangles can be seen on the slide. So you can see at the top there the traditional lost time injuries or lost time accidents and fatalities, and API has suggested losses of primary containment of greater consequence be reported as Tier 1 process safety events or process safety incidents. That's what PSI stands for. LOPC is loss of primary containment. As we go down, you can see the restricted work and medical treatment cases or recordable injuries, and LOPCs of lesser consequences, Tier 2. Events of least or no consequence make up the bottom two layers of each of the triangles, and you can see there first aid cases and behaviours and conditions and hazard reporting for personal safety, and for process safety it's challenges on the safety system as effectively near misses for Tier 3 events, and down the bottom there you have operating discipline or operations integrity management system, KPIs, as your Tier 4 performance indicators. So it's fairly useful to use the same number of levels and the same relationship between each of the tiers, because this design allows an easier transition into industry use than what otherwise would have been possible, because we already understand why the personal safety triangle is the way it is. There's a lot of text on here, but I'm not going to read it all, fortunately, and I'm sure you don't want me to at this time of the afternoon. But I'll just generally talk about it. The reason I put it up there is to show you that Tier 1, Tier 2, Tier 3 and Tier 4 in API are fairly prescriptively defined. Major accidents on a particular site are rare, and therefore it's not useful to set a KPI around a major incident rate. I don't think any of the companies represented here have one of those, or even to count major incidents to determine your success in avoiding them. A count of 0 over a particular year may tell you nothing about the probability of your site incurring one the following year. Of course, if you had enough major accidents to generate useful data, you would no doubt be out of business fairly quickly and possibly in jail. Precursors to major incidents tend to occur more often and therefore form the basis of the most severe process safety indicators called Tier 1. And that's the reason why the top of the triangle for process safety doesn't have number of explosions, because you can't really tolerate even one of those. Right, these precursors are listed on the slide there, and they include things like large gas releases down the bottom. The indicator is analogous to a lost time injury for personal safety. Tier 2 indicator measures incidents that represent effectively an order of magnitude less than Tier 1. It's still considered lagging, but obviously is predictive of Tier 1 events. Medical treatment and restricted work injuries that we're familiar with are the Tier 2 event personal safety equivalent. Tier 3 consists of those process unit fires and gas leaks that don't reach the Tier 2 threshold, as well as demands on safety instrumented systems, pressure relief devices, and process deviations or excursions that under different circumstances could have led to a loss of primary containment. The indicator, as you can understand, is more predictive or so-called leading, and can be considered the equivalent of a personal safety near miss, and can be defined as a process safety near miss. And finally, the fourth tier consists of indicators that measure the integrity of risk control or protective barriers. Operating discipline or operations integrity management system performance indicators can be used to gauge the health, or that are used to gauge the health of the integrity management system itself, or the safety management system will feature heavily here. Examples include safety critical device PM compliance, operator competency, and mechanical integrity inspections completed on time. Because these metrics will differ from plant to plant, there's no intent for collection and benchmarking of this group of performance indicators presently, either by API or OGP. They're intended to be site-specific. A number of publications now exist that provide guidance on selection and implementation of quantitative leading risk control barrier indicators, including the OECD guidance on developing safety performance indicators and the HSE's brilliant guidance document on developing process safety indicators, and it's labelled HSG 254. That's another very good document that you can download from the web. Risk control barriers are usually depicted in the form of J. Reason's accident trajectory model, or as we're probably familiar with it, the Swiss cheese model. And process safety incidents will only ever occur, in fact, after the failure of multiple barriers in this model. So the key is to define the main barriers to be monitored for defects. The HSG approach sets indicators to identify defects in selected barriers, like I was just saying. It uses a concept of dual assurance, where each barrier is monitored by a lagging indicator and a leading indicator. If the lagging indicator is 0, it indicates that that barrier has no holes. The leading indicator should never be 0 if the barrier is working. It's an approach that was explicitly endorsed by the Baker panel. And as an example of this, say your safety instrumented system, your emergency shutdown valves, a leading programmatic indicator would tell you the percent of tests completed on time. The corresponding lagging indicator for this example may be the number of failures on demand of the ESDVs over the corresponding period, or even the number of times that the ESDVs are demanded to operate. Indicators at this level can be classified in 3 groups: operational control indicators, monitoring the actual process controls for excursions; risk control system indicators, looking at effectiveness of work control systems such as management of change, permit to work, contractor control and selection procedures, etc. And thirdly, program indicators like the percent of inspections complete, percent of safety audits done. Moving on to what the task force has done over the last year and a half. We were charged with adapting lagging KPIs for upstream ministry reporting. Adapting in this case meaning adapting from what has currently been done. As you could see before, there's been years of work put in by multiple associations around the world, and it wasn't our intent to start from 0, ignore the great work that's been done there, and come up with our own independent system. But by adapting, it means that we incorporate upstream terminology, definitions, thresholds and examples, because as I was saying, API really represents the downstream industry, and so the Asset Integrity Task Force needed to review that particular recommended practice to determine whether it needed to be augmented in any way. Additionally, the task force was asked to identify Tier 3 and Tier 4 leading KPIs for asset and or company internal use, and of course, like I was just saying, the work should be congruent with CCPS, OECD, API, ANC work, etc. Again, I've just stated, OGP won't be producing an upstream equivalent to the API 754 recommended practice, as it can be used by the upstream industry with minimum modification. But we have prepared an interim interpretation guide for API 754 that will be issued imminently by OGP to its members to allow gathering of Tier 1 and Tier 2 data for the 2010 reporting year. Finally, two current OGP documents will be modified to provide guidance for use of API recommended practice and reporting of Tier 1 to Tier 4 KPIs following this year in 2011 and onwards. Right, we did conduct a detailed review of the recommended practice, and in our interpretation guide included upstream specific activities and operations such as drilling and production that were omitted obviously from the API document. We also included upstream specific chemicals that augment the threshold table that exists in the API document, and also we're building upstream specific scenarios that enable better interpretation by operators of how to use the recommended practice, and that'll be issued with the final guidance document, one of the two documents that we're modifying and upgrading and reprinting by the end of this year. The task force has conducted and reviewed returns from an industry survey conducted late last year on current asset integrity data collection and analysis from its members, and found fairly good correspondence between companies' data collection with the types of events included in the Tier 1 definition, so that's encouraging. So on that basis, we've decided to solicit asset integrity data from members for 2008 and 2009, so we can start building up some baseline prior to this year as well. Like I was saying, the two current OGP documents were identified as requiring modification. They'll provide upstream guidance for upstream use of 754 and reporting of Tier 1 and Tier 2 KPIs, and also on a recommended structure for the adoption of Tier 3 and Tier 4 KPIs. The additional publication supplementing the Asset Integrity Guidance publication 415 will replace the interim interpretation guidance for 754 that I just explained we're producing and will send out to members imminently. The Health and Safety Users Guide Report 416, which is the guide that mandates a form of template in order to collect from members' personal safety data, will be modified so that from next year, process safety data and personal safety data can be collected from the 72 members contemporaneously. Similar to the value gained in benchmarking the lagging personal safety metrics that we've seen over the past 10, 15, going on 20 years, whereby you can compare your site with other upstream sites, upstream with downstream oil and gas facilities, and even compare between industries on lost time injury rates and total recordable injury rates. Benefits would be seen in ultimately unifying the benchmarking of the lagging process safety KPIs with the downstream industry. And that's why we're pretty keen to stay fairly close to the API definition for downstream. In 2011, the task force will review the API's current definition of process safety event rate, which is simply the number of Tier 1 events normalised by man-hours worked by the company, but excluding man-hours that are expended on major construction projects. I note that API is considering using plant throughput amongst other normalisation options to benchmark PSE rates for downstream assets, and what we'll do as a task force in 2011 is consider other methods of normalisation, such as normalising on the basis of maintenance effort, the type of process, and even mechanical units, as is used in the refining benchmarking and LNG benchmarking schemes these days and for the past 10 years. The 2011 work will also take the HSG 254 and OCD approach to Tier 4 metrics and development of leading indicators around which tolerance range is defined. A selection of a few key system level indicators such as maintenance systems, integrity systems, safe systems of work that roll up a number of more detailed lagging and leading indicators coupled to provide dual assurance that I was talking about before a few slides ago, can be represented as a kind of dynamic dashboard. This diagrammatic representation of such a report allows data to be assimilated very quickly, and this is really important, of course, if line management right up to the very top needs to review this data on a regular or semi-regular basis. The task force will look at recommending the adoption of dashboard models for Tier 4 performance indicators. Some of the advantages of these dashboards being they're a simple view of current status and direction of both leading and lagging indicators that you select. There's a clear warning sign driven from potential for failure of multiple barriers. So it's, if you like, an electronic version of the Swiss cheese model, where if you see 2, 3, 4 of your 7 or 8 barriers you choose start to go red, it means you really better take a strong look at your operation. And if you've got your managing director looking at that, because it's easily assimilated, that is a message that goes fairly cleanly up to the top. It was one of the criticisms that both the CSB report and the Baker panel had of BP, in that their CEO was effectively blind to process safety risks at processing facilities. And the third advantage is information is available to all levels of the organisation if you put it on, say, a company intranet. I think this is my final slide. Now, the excellent adoption of the HSE dashboard approach of Maersk Oil North Sea was presented to the task force and other member companies' representatives in a workshop that we held last September. This is what I was just talking about, and it's probably a best practice in the industry. The workshop entailed presentations from companies, industry associations and regulators such as the HSE, from which I extracted this example, API and CCPS. So the task force has attempted to keep itself abreast of rapid developments with workshops and even with the composition of the task force itself. As I was saying, we've got the UK regulator on board, and we've also got a member of the API 754 committee on our task force as well. In our upcoming workshop in Houston in June, an afternoon will be spent aligning OGP's work with APIs and CCPS's. It's our job to ensure that our deliberations as a task force are not only representative of the upstream industry's interests, but are informed through cross-industry association. So thank you for listening to me in this very hard double graveyard session. Thanks a lot.